Hello everyone. In this session, we will discuss worksheet questions based on the chapter Electric Charges and Fields. Get ready. Two charges 10 microcoulomb minus 10 microcoulomb are separated by 10 centimeter. The magnitude of force acting on another charge 5 microcoulomb placed at the midpoint of line joining the two charges will be. Let me draw the picture for the given things. Plus 10 microcoulomb minus 10 microcoulomb are separated by a distance 10 centimeter. Another 5 microcoulomb placed at the midpoint. Okay. Two charges will be midpoint. The force acting on. See, this charge will experience force in this direction, repulsion, because both are positive charges. I can call it as F1, and let us write F1 magnitude. F1 is equal to 1 by 4 pi epsilon naught into Q1 Q2 by R square, 9 into 10 to the power of 9 into Q1 10, Q2 5 into 10 to the power of minus 6 into 10 to the power of minus 6 for both microcoulomb of charges. R value, this distance will be 5 centimeters only because that is at the midpoint. 5 into 10 power minus 2 square. Now that is equal to 9 into 10 to the power of 9 into, this is 5 into 10 power minus 6, 10 power minus 6, 10 power minus 12, 10 to the power of minus 12 plus 1 by, this is 25 into 10 to the power of minus 4. Now this is going to become 9 into 10 to the power of 9. This is minus 11, this is plus 4 by, what is that? 25 will go 5 times. So just 5. So it gets simplified as 9 by 5 into 10 to the power of 9 plus 4, 13. 13 minus 11, 2. This is Newton. Next, F2 is equal to, this is negative charge, this is positive charge. So positive charge is getting attracted by a negative charge. So this will experience, because of this charge, this will experience a force this direction only, another F. So that F2 equal to 1 by 4 pi epsilon naught Q1 Q2 by R square. After substitution, 9 into 10 to the power of 9 into Q1 is 5 microcoulomb, Q2 is 10 microcoulomb into magnitude only we have to consider because directions already I took, 10 power minus 6 into 10 power minus 6 by 5 square, 5 into 10 to the power of minus 2 whole square. Same expression you see, this expression same. So this is also 9 by 5 into 10 to the power of 2. Now net force, F net equal to, this color won't be good, I want to take this. Net force is equal to, both the forces are equal, so I can take 9 by 5 into 10 power 2 into 2. So it will be 9 2s are 18, 18 into 100 by 5. 100 by 5 is 20. So 18 into 20, 2 18s are 36, 360 Newton. Option A, 360 Newton. Okay, next. Usually I won't use blue color, I'll use better one. Three charges are arranged on the vertices of a right angle triangle. Three charges, one is minus q, one is minus q, one is plus 2q. As shown in the figure, the magnitude of dipole moment of the combination of the unit of, see, in the unit of coulomb centimeter, in centimeter only he want. Okay, fine. Dipoles. So we can have like this. This is minus q, this is also minus q, this is 2q. See, this can be split into dipoles like this. First of all, whether it is forming a dipole or not, how to check? Just sum of all the charges. If it gives 0, then definitely they can be dipoles. So sum of all the charges 0, definitely I can have a sum of all the charges. Q net 0, that means dipoles. Now I am splitting this into Q and Q, one Q, another Q. this q and q will become a dipole and this q and q will become another dipole. That means dipole direction is minus q plus q, negative to positive and away. This is the dipole direction. So negative to positive and away, one dipole direction will be like this. I can call it as P1. Another dipole negative to positive and away, another dipole direction will be this way because it is negative charge and it is negative charge. This is positive charge. So negative to positive and away, it is another dipole P2. So distance between them is also equal. Huh? Can you say like that? No, 30 degrees side and 60 degrees side, how can they equal? Cannot be, right? So distances will come like this. This is 10 cos 30. This distance is 10 cos 30 and this distance is 10 sin 30 or 10 sin, okay, 10 sin 30, opposite side. So now dipole moment P1 is equal to, dipole moment P1 equal to 2a, that is nothing but distance. 2a into q is the formula. 2a is distance, that is 10 cos 30. P1 I am writing 10 cos 30 into 1q, magnitude of 1 of the charge. 10 into root 3 by 2 into q. This will be 5 root 3q. And P2 is equal to 2a into q here again. So that means 10 sin 30, 10 sin 30 into q. This is 10 into 1 by 2 into q. So it is 5q. Now both are perpendicular. P1 is perpendicular to P2. So resultant dipole moment, resultant is equal to square root of perpendicular, right? Square root of P1 square plus P2 square. So square root of P1 square, 5 root 3q square plus 5q square. So here I'll continue here. P resultant is equal to 5q common. 5q will come out common. This is root 3 square plus this is 1 square. So root 3 square is 3, 3 plus 1, 4. 4 will give you 2. 2 5s are 10, 10q. And q value not given. So let us see the options. Without seeing the options, we did this much. 10q, 10q, 10q. So D option. Yeah. I'll do one thing. As options are getting disturbed by my picture, so that's why I have to first show the options, isn't it? Yeah, now I will try again. So what's that I have given? This is minus q, this is 2q. I split 1q here, 1q here, and this is one more minus q. Okay, now the dipoles are minus q2 plus q, one dipole, and minus q2 plus q, one dipole. So two dipoles I have taken like this. Okay, next. An electron is released from a distance of 4 meters from a stationary point charge electron. QE is released from a distance of 4 meters and a point charge Q is equal to 20 nanocoulomb, 10 to the power of minus 9 coulomb. What will be the speed of the electron when it is 2 meters away from the point charge? What will be the speed of the electron when it is 2 meters away? The distance d2 is equal to 2 meters away. What is the speed? So work done concept, and many things are given here. Charge of electron 1.6 into 10 power minus 19 coulombs, mass of electron 9 into 10 power minus 31, and 1 by 4 pi epsilon naught value is 9 into 10 to the power of 9. 1 by 4 pi epsilon naught. Using work done mode we can do, that will be easy. 1 by 4 pi epsilon naught, because force is variable, so you can't do with the force. Potential difference concept will be better for this problem. That is, you see, at a distance 4 meter, what is the potential? V1 is equal to 1 by 4 pi epsilon naught. I am taking it as k dash. I am taking it as k dash. 1 by 4 pi epsilon naught q by r is the potential. R1 I can write, and V2 is equal to k dash q by R2. Potential difference is delta V is equal to k dash q by R2 minus k dash q by R1. Potential difference into charge q, that will give you work done. So into, this is charge of electron. So into QE will give you work done. This work done is equal to half mv square, half mv square. Now we need to find out that thing. So K dash Q will come out and QE also will come out. Inside 1 by R2 minus 1 by R1, not squares, it's potential. Potential won't have square. And that is equal to half mv square. So we want. So V final expression I'll write. V is equal to root over 2 K dash Q QE into R1 minus R2 by R1 R2. M is there, R1 R2 is there. So substituting and we will find out the answer. So square root of a big expression will come. 2 into 9 into 10 to the power of 9 into Q value 20 nanocoulomb, 20 into 10 power minus 9 into charge of electron 1.6 into 10 to the power of minus 19 into R1 minus R2, 4 minus 2 is 2, 4 minus 2 is 2 by M mass 9.1 into, here 9 only he gave, into 10 to the power of minus 31 kg into R1 R2, 4 into 2. So this gives rise to, I don't want to waste the time, 4 into 10 to the power of 6, 4 into 10 to the power of 6 meters per second. This is the concept. What is that? Work done against the potential energy, that means potential difference into charge is equal to change in kinetic energy. You can have that concept. A thin non-conducting ring of radius r has a linear charge density. Non-conducting ring of radius r is having lambda is equal to lambda naught cos phi. Okay, is a constant phi is an azimuthal angle, and the magnitude of the electric field strength at the center here E is equal to how much electric field. So here you need to know a little concept about azimuthal angle. Let's continue. Azimuthal angle should be measured from north direction onwards, but here we can take from the top point onwards. That will be better here. Okay, and next this picture will become very close, that means very small. I want to draw a big picture, so let me draw a bigger picture. Big picture, Chui, this much. Okay, so here I am taking an elemental length dl, and you know dl is equal to r into d angle. Here I want to take this angle d phi, and from north onwards we have to take, so this is phi. So dl is equal to r d phi, l is equal to r theta, like that only. Okay, dl. And what about charge it is going to get? dq. How much that is? dq is equal to lambda into dl. Lambda is lambda naught cos phi. Here he gave lambda naught cos phi into dl is r d phi. So this is dq. Just put aside. It's a big problem, not a simple one. Now similarly, one more element you can consider on the left side also. One more element. So that element will have this way, same, identical, same. This is also phi only, this is also d phi only. Then this will cause a field like this, which I can call as dE2, and this will cause a field like this, which I can call dE1. This is dE1, this is dE2, and if you resolve them into two, one will come this way and one will come this way, one component. What is this component? If this here also phi will come, here also phi will come. So this is sine component, dE2 sine phi. This is dE1 sine phi. These two gets cancelled. That I will mention here. What is that? Sine components cancel each other. Sine phi, sine components cancel because they are opposite. That's why. Okay. Next, cos components. I want to draw with another color. So here one and the other one. Both will be equal only because dE1, dE2 are similar things, right? dE1, dE2 are similar things. This is another one. So this is DE2 sine cos phi, and this is DE1 cos phi. So net field will be downwards. E net is equal to because of the upper region it will be downwards, because of the lower region it will be upwards. But if it is not a uniform ring, then net field not equal to 0. If it is a uniform ring, then net field will be 0. If it is a good question, for some students you have to put another option, that is 0. Then if it is uniform ring, 0 is also correct answer, but it's not a uniformly charged ring. The charge is different. Yeah. So E net is equal to 2DE cos phi, and 2 times of integration is from 0 to phi value is running from 0 to pi, and 2 integral, what is dE? 1 by 4 pi epsilon naught. What is dq? Lambda into dl, that is I'll write first formula, k dash dq by r square into cos phi. This is, so 2 k dash by r square is invariant, cos phi integral, and dq lambda naught cos phi, and here is one more cos phi, cos square phi, and r d phi is also there. I'll write entire thing normally, whatever we have, lambda naught cos phi r d phi into cos phi by r square I took out. So this is d phi is the operator, cos phi is the variable. So 2 k dash lambda naught cos square phi will be inside. So 1 r gets cancelled here. So 1 r gets cancelled. So in the denominator r will be there. R. Anything else? So cos square phi d phi. Cos square phi shouldn't be integrated directly. It should be converted into 1 plus cos 2 theta. 1 plus cos theta equal to 2 cos square theta by 2. Using that you have to convert it, and you need to do. So I don't want to waste the time. I'll write E net is equal to, so after this we are going to have lambda naught by 4 epsilon naught r. So this will be the final expression. What's that? Yeah, C. It's not a simple question, somewhat bigger. Think big. Next. A cube of side L has a point charge Q located at 7 vertices. 1, 2, 3, 4, 5, 8 are there. So 7 vertices, charges are there. Okay. Minus Q at remaining 1 vertex. Fine. The electric field at its center is found to be A times of Q by 4 pi epsilon naught L square. Okay. Magnitude of alpha. That is not A, alpha. Okay. Alpha. This is alpha. Okay, fine. Actually, if all the charges are present, then field due to whatever the if all the charges are present, field due to all these charges at the center will be 0. If all are present, field due to all charges will be 0. If one is absent, that field will be left out. Suppose if one is absent, that field will be left out. See, here you can take this direction. Yeah. Suppose this is also plus, it will be 0. Suppose if it is absent, then what happens? He is going to give a field like this, that will be unbalanced. So he is going to have a field like this because of absent. I can call EA. And it is a negative charge. That means one more field will be there. That is E negative, En. So totally here unbalanced field is E unbalanced is equal to E unbalanced is equal to 2 times of EA, whatever. 2 times of both, because of negative charge the direction is decided. So you can take the magnitude K dash Q by distance square. Distance will be L is the cube, what you call cube side is L. Then it is half of the body diagonal. Body diagonal root 3L. Root 3L is body diagonal. So R is equal to body diagonal by 2 equal to root 3 by 2L. So that we have to use. 2 K dash is K dash only in the question. Q is Q question only. And this is root 3 by 2L square. So it is equal to 2 k dash q by 3l square into 4. So it will be 2 4s are 8, 8 by 3, 1 by 4 pi epsilon naught q by l square. So 8 by 3 is a particle of mass a particle of mass m is equal to 2 into 10 to the power of minus 6 kg with a charge q is equal to 5 into 10 to the power of minus 6 coulomb is hanging in air above a similarly charged conducting surface. Similarly charged means this is positive, that is also positive, maybe I feel. The charge density of the surface is, okay, similarly, so that means mg is balanced by, mg is downward force, is balanced by upwards force due to field, that is eq, that is equal to sigma by 2 epsilon naught into q. So he is asking this sigma. M is 2 into 10 to the power of minus 6, g is 10, and into 2 into epsilon naught value is 8.85 into 10 to the power of minus 12 into 2 by the charge q value 5 into 10 to the power of minus 6 is equal to sigma. So any cancellations? Zook, 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 zook. Anyway, this is a simple mathematical thing only, you two can do. I got, SARS will have advantage 35.4 into 10 to the power of minus 12 coulomb per meter square, right? Yeah, it's verified, double checked, you can do. Next, two small conducting balls of identical mass 20 gram, two small conducting mass 20 gram, right? Mass m is equal to 20 gram and identical charge q is equal to 10 to the power of minus 10 coulomb hang from a non-conducting thread of length L is equal to 300 centimeter. If the equilibrium separation of the ball is x is lesser than L, then the magnitude of xc is, okay, it should be treated like this. So this theta I don't want actually, right? What is the asked? In equilibrium separation of ball is x, separation is x. This he is asking x and he wants that. Okay. See, if I would like to take it as r up to here only, up to here I want to take as r. I repeat, up to here from the center I want to take it as r. From the center I want to take it as r. This is r. This is also r. Of course, 2r is equal to x. So r. Now this is going to have a force F due to electrostatic, due to gravity mg. So we have from the known sources so many times, that is equal to F by mg is equal to tan theta s. So I don't want to waste my time. May I write? This is L. Okay, or okay, I'll do it for you once again. What's problem for me? That is another color. Yeah, this will have a tension T. The T can be resolved into two components. So T cos theta, this is theta. So T cos theta is this one. T cos theta balances mg and T sin theta balances F. So tan theta is equal to F by mg. Now what does he want? X. Okay, F is equal to mg tan theta, and L and X is very, very small, he said. So tan theta can be theta. Theta is equal to, I can call it as X by L. I can directly take. Anyway, so F is equal to K dash Q1 Q2 by X square is equal to mg tan theta. I want x, so that you can simplify. That we are going to have like this. Further, as I told, when theta is small, tan theta is equal to theta, which is nothing but r by L, which is nothing but x by 2 L. So r is equal to x by 2, right? R is equal to x by 2. So like that. So I can replace that also here, so that it will be k dash q square by x square into equal to mg into x by 2L. So we are going to have like this. X cube, I want x actually, that's why x cube is equal to x square into x cube. K dash q square 2L by mg. Now let us substitute. X is equal to cube root of k dash value 9 into 10 to the power of 9. Goodness, it's a big simplification. 9 into 10 to the power of 9 into q square. This space is insufficient. I'll write at the side place. It will be better. That is equal to, yeah, x cube. X is equal to cube root of k square, k 9 into 10 to the power of 9, q square 10 to the power of minus 20, 2L, 2 into L. Answer in terms of L or no? Length of the string. Length of the string not given, huh? Then identical, length of the string is given 300 centimeters. 300 centimeters. 300 centimeters means 3 meters. In SI system we need to do, right? Yeah, L is given. L is given. L equal to 300 centimeters. Okay, 2L. mg, 20 gram, 10 power minus 3, G 10. So I would like to take the advantage once again. This is cube root, not square root. 9 3s are 27. So cube root will come 3 and 2 gets cancelled. Wow, it's easy. Such calculations I will do. 3, B option is having 3, C option is having cube root of 3. So obviously B option, I did it 1 by 3. So respective units will come actually. Units that you have to check. Option B, yes. Next. A solid sphere of radius r1 is equal to 1 centimeter, carries charge distributed uniformly over it with a density rho is equal to minus 3 coulomb per centimeter cube volume charge density, and is surrounded by a concentric spherical shell of R2 is equal to 2 centimeter, carrying uniform charge density rho2 equal to plus half coulomb per, carrying uniform charge density rho2. This is coulomb per centimeter square. It should be checked again. If ED denotes the magnitude of the electric field at a distance d from the common center, then okay, D is 1 centimeter logic only. He is asking R1 is equal to 1 centimeter. That means he is asking electric field on the surface of the inner sphere. Surface on the inner sphere, inner one and outer one. So this is 1 centimeter only, no? That's why. And this is 2 centimeters. And here is another one type of row is there. Here is one type of row is there. Okay. And these are all spheres. And the second one is also shell. Second one shell, first one sphere. As it is a shell, it must be only sigma. It is not rho2 actually, it should be sigma. And half coulomb per meter square. Yeah, it's aerial charge density, it's volume charge density because it's a sphere. As the outer one is a shell of charge, its field inside will be 0. So outer one you no need to consider. Only inner sphere you have to consider. Inner sphere, suppose this one, and you want field here. That means field will be due to only the charge whatever inside, and this is distance d. So coming to Gauss law, flux E into 4 pi d square is equal to, flux is equal to 1 by epsilon naught times of charge enclosed in it. So E into 4 pi d square is equal to 1 by epsilon naught times of charge inside. Charge inside is rho into 4/3 pi r cube, right? So 4/3 pi d square will go. So E is equal to 1 by epsilon naught times of rho into d by 3 is there. Okay, and rho value is also 3. So 3 gets cancelled. minus 3, of course negative answer will come, minus 3 by 3 into d by epsilon naught. So that is equal to minus d by epsilon naught. Minus sign indicates inward flux, inward field, inward. This minus sign indicates inward field. So option is D. It's already. A large charged plane having surface charge density rho is equal to surface charge density. So sigma I have to write. Sigma is equal to 4.9 into 10 to the power of minus 6 coulomb per meter square. Lies in the xy plane. Okay. The circular plane of radius 1 centimeter, r is equal to 1 centimeter, is lying completely in the region where x, y, z coordinates all are positive. When the plane is normal, makes an angle 60 degrees with the z-axis. Z-axis. Electric flux through the circular plane is. So here the field of the sigma sheet is there, and it is making an angle. It is making an angle of 60 degrees with it. 60 degrees with it. Then what is he asking? The plane normal makes 60 degrees with z-axis. Electric flux phi is equal to how much through this? That's what he is asking, right? Let's go. That is from flux phi is equal to sigma by flux phi equal to E bar dot A bar, isn't it? Nothing but EA cos theta. Is it okay? E is sigma by 2 epsilon naught and A is given already, of course pi r square into cos 60. So that is equal to sigma value 4.9, 4.9 into 10 to the power of minus 6 by 2 into epsilon naught value, epsilon naught value 8.85 into 10 to the power of minus 12 into area pi r square, pi into r square. Then we can do like this. Anyhow, in the numerator pi is there. So epsilon naught can be written like this. Will be easy for us. 1 by 4 pi epsilon naught is equal to 9 into 10 to the power of 9. That means 4 pi is 4 pi epsilon naught. We want what? We want epsilon naught value. Okay. Epsilon naught value is equal to 1 by 4 pi into 9 into 10 to the power of 9, one can write. So that will come on to the numerator, 1 by 4 pi into 9 into 10 to the power of 9. And here is pi is there, and pi r square is there. R is 1 centimeter, 1 into 10 power minus 2 square into cos 60, 1 by 2. So it's a simplification you can do. Yeah, 1 by 4 pi epsilon naught 9 into 10 power 9. 1 by 4 pi 9 into 10 power 9 is epsilon naught. Epsilon naught value is here, you substitute. Then after simplification, it's hardly 43.56. It's coming 43 or 48. 43 is preferable. Yes, option A. Newton meter square per coulomb. Let V1 be the potential at the center of the square of side A 1 meter. And charges at 4 corners are 2 coulomb each. And if the same charges are placed at the corners of a square of side 2 meters, then the potential at the center of the square will be V2. What is V2 by V1? Excellent. This is square. This is another square. Charges are same. 4 corners, 2 coulomb each. 2, 2, 2, 2, 2, 2, 2, 2. Okay. 1 meter each. And here it is 2 meter each. Then here the potential is equal to, here V1 is equal to K dash Q by R. This distance is totally, suppose say initially A. This is A by root 2. A by root 2. A by root 2 means 1 by root 2. So 1 by root 2. I can write 1 by root 2. And V2 is equal to, at the center only, same charges, but this distance will be different. That is A by root 2. Here also A by root 2. So A is 2 meters. Here A equal to 1 meter. So this is 2 by root 2. So K dash 2 by root 2. And he is asking V1 by V2 by V1. V2 by V1 is equal to K dash 2 will go. And this is going to become root 2 will go root 2 times. So this is K dash 2 by root 2. And this is K dash 2 root 2. Yeah, V2. V2 is equal to K dash 2 by root 2 into V1 is equal to V1 1 by K dash 2 root 2. K dash 2 will go. So this is 1 by 2. 1 by 2, option A. Should be patient enough while solving and simplifying. Electrostatic force between two identical charges placed in vacuum at a distance of R is equal to F. Electrostatic force between two identical charges placed in vacuum at a distance R is F, vacuum. So F is equal to, okay, K dash Q1 Q2 by R square. In vacuum, this is vacuum, okay. Then a slab of width R by 5 and dielectric constant D equal to R by 5, dielectric constant K equal to 9 is inserted these two charges. The force between the charges is, now F dash is equal to how much? F dash is equal to K dash Q1 Q2 by effective distance will be R minus T plus T root K whole square. This is effective distance. So here D only T. Now let me simplify this. F dash is equal to K dash Q1 Q2 by R minus T value R by 5 plus T root K R by 5 root over K value 9, yeah, dielectric constant 9, and it's a square, don't forget squaring. So this is equal to K dash Q1 Q2 by 5 ones are 5R minus R 4R by 5. 4R by 5 plus this is 3R by 5 whole square. Again 7R by 5 whole square. Yeah, K dash Q1 Q2 by, this is 7R by 5 whole square. So F dash is equal to K dash Q1 Q2 by 49R square into 25. So this part is F only, no? So 25 by 49 F. So this is, you have to notice this only. Effective distance when dielectric slab is placed is R minus T plus T root K, where T is the thickness of the slab and K is, next, two opposite charges each of magnitude 500 microcoulomb or 10 centimeter apart. Q is equal to 500 microcoulomb, A 10 centimeter apart. 2A is equal to 10 centimeter, 10 to the power of minus 2 meter. This is 10 power minus 6. Find the electric field intensity at a distance 25 centimeters from the midpoint on axial line of the distance. From the midpoint on axial line, okay. It's, you can't treat it as a short dipole. You have to treat longer dipole only. Long dipole only you have to feel. Electric field E is equal to 1 by 4 pi epsilon naught 2 pd by d square minus a square whole square. Full formula, big formula only. 9 into 10 to the power of 9 into 2 into p is 2a cube. 2a into q. P is 2a into q. I wrote 2 times 2. 2a cube. 2a is 10 centimeter into 10 to the power of minus 2 and q is 500 into 10 to the power of minus 6 by d square minus a square. Where is d square? 10. 10 into 10 to the power of minus 2 whole square, d square minus a square. Oi, distance is, I wrote 2aq only, right? Yes, you reminded me excellently, very good. I didn't write d value in the numerator. D value is 25 centimeter from the midpoint, 25 into 10 power minus 2 by d square, 25 into 10 power minus 2 whole square minus a square. A is 5 into 10 to the power of minus 2 whole square. This is d square minus a square now whole square. This is the expression and you need to simplify this. Simplification will be done by you, I know, no. That is 5 sin 76 into 10 to the power of 7 Newton per coulomb. I checked it. It's verified book. Don't worry. Next, you do it. By the time, meanwhile, I can simplify that. I can explain 2 more questions, right? What is the electric flux for Gaussian surface A that encloses the charged particles in space, in free space? Come again. What is the electric flux for Gaussian surface A? Okay, A is the full Gaussian surface. Okay. Encloses the charged particles in free space Q1, Q2 and Q3. Okay. Gaussian surface A. What is the flux through it? Flux phi is equal to 1 by epsilon naught times of total charge enclosed in it, Q1 plus Q2 plus Q3. That is equal to 1 by 8.85 into 10 to the power of minus 12, and Q1 is minus 14 plus 78.85 minus 56 nanocoulombs into 10 to the power of minus 9. So this obviously will give you in the order of 10 to the power of 3. So all are of 10 to the power of 3 only, the number you can do. So 1 will come, right? 14, 8 point something will come, right? Yes. So next option A it is. Yeah. Let us see the next question. The question is, okay, picture cut. Fine. A charged cork ball having mass 1 gram and charge Q is suspended on a light string in a uniform electric field as shown in the figure. The ball is in equilibrium at theta equal to 37 degrees. Theta is equal to 37 degrees. It's in equilibrium. When the electric field E is equal to 3I plus 5J into 10 to the power of 5 Newton per Coulomb. Assume T is tension. Which of the following options are correct? Given sin theta value and G value. Options: charge Q value, tension T value. Okay. Charge mass M is equal to 1 gram and charge Q is equal to Q only. Okay, that we have to write. So we have tan theta is equal to F by mg. We have this formula, and the ball is in equilibrium when the electric field E is given 3I plus 5J into 10 to the power of 5. And that electric field is not horizontal, not perpendicular, it's in a different way. So tan theta equal to mg tan theta value how much? 37. Okay, tan 37 is equal to mg. F is equal to mg. Okay, F is equal to EQ. I can write whatever U into Q in that direction. Okay. Even if the field is horizontal, then this formula holds good, but the field is not horizontal, then we'll go for resolving the field, and we can go in a better way than these two steps. We can go in a different way. That will be better, what I feel. Suppose, yeah, here is the pendulum. Its field is like this, E. So it's already component wise. Ex will be there, into Q will be force. This will be tension T. So this is T sin theta will come like this, and T cos theta will come like this. This is T cos theta. T cos. Of course, Ey into Q also will come this way only. Ey into Q also will come like that, and mg will be downwards. So I can say simply Ex into Q, X component into Q, will balance T sin theta, and Ey into Q plus T cos theta is equal to mg, implies T cos theta is equal to Eyq minus mg. So tan theta, okay, on dividing, tan theta is already there. Here he is asking charge Q as well as tension. I will go for squaring and adding the things. That will be better. Already sin 37 is also given, and cos 37 automatically comes. No need actually. Yeah, squaring and adding will give you tan theta is equal to sin by cos will come. This is 1, this is 2, and just easiest way I am finding Ex into Q by Ey into Q minus mg. All are known things, I think, except Q. So tan 37 is tan 37 is 3 by 4. 3 by 4 is equal to Ex. Ex means 3. 3 Q I don't know by Ey. Ey is 5 into Q and into 10 to the power of minus 5 plus 5 is there. Here also 10 to the power of plus 5 is there. Minus mg, m value 1 gram, 10 to the power of minus 3 into g value 10. So from here onwards I can find Q value. Q is equal to 11 into 10 to the power of minus 8 coulombs. So 11 into 10 to the power of minus 8 coulombs. Q. Next, we have tension T is equal to, first equation we can use T equal to Exq by sin theta. Ex value 3 into 10 to the power of 5 into Q value 11 into 10 to the power of minus 8 by sin theta 0.6. So this is going to become 5.5 into 10 to the power of minus 3 newtons. Now, so here two options are correct. Charge we got correct, T we got correct. Both are correct options. So he gave only one. Actually Q also correct. Maybe it's a multi-correct answer question. Multi-correct question it is. 3 charges 4Q, Q are placed at position 0, 1 by 2, 1 respectively along a straight line. At 0 and at 1 by 2, at 1 we have 4Q and Q and Q. A straight line. If the resultant force on Q is 0, then capital Q is equal to resultant force on small q is 0. This is experiencing 0 force. Then what is capital Q? Okay. Resultant force on capital Q is small q, K dash Q by 1 by 2 square plus K dash Q 4Q by 1 square equal to 0. K dash gets cancelled, Q gets cancelled. Capital Q into 4 plus these two left out. 4Q is there equal to 0. That means capital Q is equal to minus 4Q by 4. That means capital Q equal to minus Q. Option A. 6 point charges each of magnitude capital Q 6, but 3 are positive, 3 are negative here. Vertices of a hexagon of side A as shown in the figure. Electric intensity on the line passing through O and perpendicular to the plane figure at a large distance x is equal to. Wow. Actually it is here like this. Whatever that hexagon he is asking here field will be at a large distance. Suppose one positive charge 1, if you observe that positive charge 1 will have a field like this. Positive 1 will have a field like this. This is positive 1, E plus. And at a long distance there is an opposite one. Opposite one we have a negative one. And this can be resolved into two components. The other one is not getting cancelled. Yeah. So the other one will have a field towards, and this resultant will come horizontal like this for this one and this one. So obviously, yes, obviously this is one positive charge, this is one negative charge. Similarly, this and this will have, and this will have. So totally 3 horizontal components will come, 3 vertical components will be there. And he is asking electric field intensity on the line passing through. Yes. So in a simplest way, we will try like this. This forms a dipole, isn't it? Because one positive charge, one negative charge. So forms a dipole. So this is field on the equatorial line for this dipole. For this dipole, it forms a field on the equatorial line. So I can call it as E. Let me draw at a neat place, not here. Here positive charge, negative charge, positive charge, negative charge. So these are all dipoles. Positive charge, negative charge. 3 dipoles are there. And here you want field. So one dipole's field is this way. One dipole's field is this way. One dipole's field is this way. At a large distance, say x. So this is E. This is also E. This is also E for 3 dipoles. And these are all 60, 60, 60 degrees. And their vertical components or other components gets cancelled. This will come this way and it will be opposite. So obviously I can have 2ex plus E, nothing but 2e cos theta plus E will be E resultant. So E resultant equal to E of 2 cos theta plus 1. E into 2 cos theta is 1 by 2 because 60 degrees plus 1. So because 60 degrees. So it is 2E. 2 into E value is k dash p by d cube. Here x cube. He said x. X is the distance. X cube. So k dash 2 p means 2a into q by x cube. That is equal to k dash 4a q by x cube. So option A, capital Q. Okay, no issue. Next. Electric field intensity at a point on the axis of an electric dipole is electric field intensity at a point on the axis of an electric dipole in air is electric field intensity on the axial line 4 Newton per Coulomb. Okay. Then the electric field intensity at a point on the equatorial line at a distance equal to twice the distance. This is distance D, this is twice the distance on the line. If the dipole is in a medium of dielectric constant 4, even here k is equal to 1, here dielectric constant is also 4. Here he missed the one point, that is it is a short dipole. I am taking it's a short dipole. Then it will be easy, otherwise it will be so long. First of all, EA expression is k dash 2pd by I am writing plus bigger ones, 2p by d cube. That will be enough. 2p by d cube. And this is going to become E is equal to in a medium. So k dash by k into p by d is 2d whole cube. This is second one. So k dash p by k value 4 and we will do 8d cube. So here one more 2 I want to multiply in the numerator and denominator, so that it is k dash 2p by d cube into 4 2s are 8, 8 8s are 64. 64 will come. 2 cube means 8 only, right? Yes. So now this one is the EA only. EA by, this is EA by 64. EA value 4 they gave into 64. That is 1 by 16. 1 by 16 is option D. Yes. Next. 3 charges each of magnitude Q is equal to 100 microcoulomb are placed at the corners of an equilateral triangle A, B, C. Equilateral triangle of 4 meter side. If the charges at A and C are positive and charge at point B is negative. Come on, A and C are positive and B is negative. Then the magnitude of total force acting on a charge at C, okay, charge at C, the angle made by it with AC is, okay, here force, all are equal. So because of A, repulsion, and because of B, attraction, So the angle between them 120, and the resultant will be angle bisector. So it will be 60, right? 60, two options are there. Okay, fine. Next. And if it is F0 and if it is also F0 120 degrees, then answer also F0 only 120 degrees, same force will come. And that F0 will be the resultant because it's at 120 degrees, that's why. And that is K dash Q into Q by distance R square. K dash value 9 into 10 to the power of 9. 100 into 100, 10 to the power of minus 12. Why? Because 10 power minus 6, 10 power minus 6. And R value 4 square. So 9 by 16 into 10 to the power of 9 plus 2 and 2, 4, 4 minus 12. This is 9 by 16 into 10 to the power of 9 and 4, 13. 13 means 1 only will come. So 90 by 16, 90, 16, I think the table will go. 16 5s are 80, huh? Okay. So 5 point something will come, 5 point something and 60 degrees answer. 5 point something and 60 degrees is A option. Yeah, next. Simple pendulum with a bob of mass m is equal to 40 gram. Charge Q is equal to 2 microcoulomb. And making oscillations T is equal to 20 oscillations in a second, then means frequency, oscillations per second. A vertical electric field of magnitude E equal to 4.2 into 10 to the power of 4 Newton per Coulomb, pointing to downwards is applied. So arrow mark reverse. So excitement. Next, the time taken by the pendulum to make 15 oscillations in the electric field, time taken for 15 oscillations. So one oscillation if I find, or frequency if I find, then I can do it. First case is time period T equal to 2 pi root L by G, everybody knows. So frequency N equal to 1 by 2 pi root G by 2. This is fine. Now this is having charge plus Q. The downward field is applied. That means its force is also downwards. Then obviously there is an acceleration EQ by M in the downwards direction. Obviously acceleration and new frequency will be 1 by 2 pi root over G plus A by L. So on dividing one with other, N by N dash by N is equal to root over G plus A by G. N dash by N value 20 oscillations equal to root over G is 10 or 10 plus A. EQ by M will calculate 4.2 into 10 to the power of 4 into Q value 2 into 10 power minus 6 by M is 40 gram, 40 into 10 to the power of minus 3. So it is 2.1 roughly, right? 2.1. So 2.1 by this is 10. So root over 12.1 by 10. 121 by 100, 11 by 10. 11 by 10. So N dash is equal to 0, 0 will go. 22 will be new frequency. And time period is 1 by 22. How many oscillations he want? Time for how many oscillations? 15. 15 into 1 by 22. 15 into 1 by 22. So N dash by N. N is equal to 20 oscillations for 44 seconds. So it is 20 by 44. 20 oscillations for 44 seconds. 20 by 44. If I multiply, then it will be N dash is equal to, implies N dash is equal to 11 by 10 into 20 by 40. 11 will go 4 times and 0, 0 will go, it will be 1 by 2. 1 by 2, 2 seconds in T equal to 15 into 2. 15 into 2, 30 seconds. So option is A. An electric dipole is situated in an electric field as shown in the figure. Okay. Remaining options. The dipole and electric field are both in in the plane of the paper. The dipole is rotated about the axis, perpendicular to the paper at a point A in anti-clockwise direction. If the angle of rotation is measured with respect to the direction of the electric field, okay, the torque for different values of the angle of rotation theta is correctly represented by, okay, in the graph torque stories are given. Okay, dipole direction is in the direction of the field initially. Initially P bar is in this direction only, field is in this direction only, and it is rotated anti-clockwise. So first torque tau is equal to Pe sin theta. First one 0 angle, 0 degrees first. Next one theta equal to 90 degrees will come. Next theta 180 will come. So tau value 0, tau value max, again tau value 180, it decreases, and then tau value again 0 and tau value increases. So like that. So sine function will come. So sine function will come. It should be second graph then, starting 0 onwards, right? Second graph means C, correct. Sine function only, no? Why to think so much? An electric field at a distance r from an infinitely long uniformly charged straight conductor. Electric field at a distance r from an infinitely long uniformly charged straight conductor having linear charge density lambda is E1. Having linear charge density lambda is E1. Another uniformly charged conductor having same linear charge density lambda is bent into semicircle of radius r. The electric field at its center is E2. Then infinite long wire at a distance r with lambda E is equal to lambda by 2 pi epsilon naught r. If it is bent into a semicircle and at a center, electric field E is equal to lambda by 2 pi epsilon naught r only. So both are equal. So E1, E2 are equal. Yes. Next question is lengthy, but you need to know some formulae so that it will be easy. Otherwise you need to derive. In the situation shown in the figure, magnitude of Q is very, very smaller to capital Q and R is very, very greater to A. Where is R? Here will be the R. Okay. And the net force on the free charge minus Q and net torque on it about O. Okay. At an instant R respectively. Okay. Fine. Distance is large and it's a dipole. No, not a dipole. Why? Because one charge is small and one is a bigger one. So that's why. Field on the equatorial line E is equal to K dash P by dq. dq means here r cube. The direction is, this is here like this and here will be this way. This way means minus I cap. Now force F is equal to EQ. That is equal to negative charge. He told negative charge. That means plus K dash PQ by R cube I cap. This is the force. Force is matching with fourth option and the first option. Next, torque. Tau is equal to R bar cross F bar. R bar is equal to R into J cap, its upward direction, cross F is K dash PQ by R cube into I cap. So K dash PQ by R square into J cross I. J after K should come I, so minus K. So A option is matching. Yeah. A tiny spherical oil drop carrying a net charge Q is balanced in still air with a vertical uniform electric field strength E is equal to 81 by 7 pi into 10 to the power of 5 volt per meter. When the field is switched off, field is balanced. Okay, switched off, the drop observed to fall with a terminal velocity in absence of field. Terminal velocity is equal to 2 into 10 to the power of minus 3 meter per second. where G equal to 9.8 meter per second square. Viscosity of air is eta is equal to viscosity of air eta is equal to 1.8 into 10 to the power of minus 5 Newton second per meter square, and density rho is equal to 900 kg per meter cube. Okay, of oil. Okay, the magnitude of Q is equal to Q on it is how much? Okay, in absence of field, the droplet is going to have downward force mg, upward force is buoyant force as well as viscous dragging force Fv. As it is falling down, those two forces will be upwards. So mg is equal to Fb plus Fv. So with this, net force will be 0, then only terminal velocity will come. That's why I took equality. Why? Because it is falling with a terminal velocity. So these two are equal. Whenever Fb plus Fv is there, then you can take mg. Next, and keep on watching. When electric field is applied, it's stationary. In that it's stationary means Fv will be 0. Fv 0 means mg is dominating downwards, minus Fb must be balanced by Eq in upward direction. Yeah. So mg is equal to Fb plus Eq. Strictly speaking, Eq equal to 6 pi eta Rv I can take. Why? Because on comparing these two equations carefully, mg, Fb, Fb, so Eq is equal to viscous dragging force 6 pi eta Rv. So we can take the necessary things. Q is equal to 6 pi, eta value 1.8 into 10 to the power of minus 5, R value radius is given. Radius not given. Mass is given. From terminal velocity you have to bring out, otherwise we can't. So net charge Q, and the field is switched off. The drop is falling with terminal velocity, G viscosity, density and magnitude. So from terminal velocity Vt is given. We have Vt terminal velocity equal to 2 by 9 R square G into rho minus sigma by eta. So taking this data into, and R value we have to find out, and R value I have to find out, and R value I have to write here, into velocity I have to write here. Velocity how much? Terminal velocity 2 into 10 to the power of minus 3 by E value, E electric field, 81 by 7 pi into 10 to the power of 5. Wow. It's a simple question. And from Vt, R value I'll calculate and I'll come. Or otherwise I'll do like this, that R value here, we have no other option. 9 by 2 into 9 by 2 eta Vt by G into rho minus sigma under root is substituted here. So that we'll get 8 into 10 to the power of minus 19 coulomb. Why should I waste time? This is the procedure. You can happily follow. Okay. Option D. Next. Procedure teaching is important for me. 4 charges Q plus 2Q plus Q and minus 2Q are placed at the corners of ABCD respectively. The force on a unit positive charge kept at the center O is. Let me take up the 4 charges plus Q plus 2Q plus Q minus 2Q are placed at ABCD. ABCD. These two are balancing. No, they are not balancing. Okay. And the force unit positive charge. Here one unit positive charge is placed. Force on it. This will repel. This will attract. And this will repel. This also will repel. So these two forces cancel. Only this is go like this. What is A, B, C, D? So BD. It's in the direction of BD. Along BD. That. This is positive charge. Now this is positive charge. So net force due to these two will be 0. Only because of these two will be there. So that's why BD. Which of the following statement is false in case of a polar molecule? In case of a polar molecule, which of the following is false? First option is center of positive and negative charges are separated in absence of an external electric field. Center of positive and negative charges are separated in which one? Polar. Polar already polarized. So they will be separated in presence of external electric field. Okay. And do not possess permanent dipole moments. And ionic molecule, what he asked, false statement. Okay. Actually they possess permanent dipole moments, isn't it? So C option is wrong. Yeah. Electric field due to infinite straight uniformly charged wire varies with distance, or electric field due to infinite charged wire lambda by 2 pi epsilon naught r. That means E is inversely proportional to 1 by r. Option B. Next. When a soap bubble is charged, its radius increases because they are going to repel. They are going to repel. So soap bubble is charged, then the radius increases. Yes. A point charge Q is placed at the corner of a cube of side A. Here. A as shown in the figure. What is the electric flux through A, B, C, D? Where is A, B, C, D? A, B, C, D. It is the phase whatever the charge is having. So 0 is answer. Only opposite phases will have the flux. Electric dipole is kept in non-uniform electric field. Electric dipole is kept in a non-uniform electric field. It generally experiences both force and torque because non-uniform. B. If it is uniform, only torque, no force. A force of repulsion of two identical positive charges. Force of repulsion between two identical positive charges when kept with a separation r in air is F. Two identical positive charges, here is plus and here is also plus, kept in a separation r in air is F. Okay. Half the gap is between the two charges is filled with a dielectric slab of force constant 4. Then the net force will be, I told no, net force F dash is equal to K dash Q1 Q2 by R minus T plus T root K is the effective distance with dielectric and square. So K dash Q1 Q2 by R minus thickness is R by 2 plus R by 2 root over 4 whole square. So this is K dash Q1 Q2 by R minus R by 2 is 1 minus 1 by 2 is 1 by 2 plus this is 2 will go. So only 1 whole square. So this is K dash Q1 Q2 by R square into 3 by 2, 9 by 4. So it is nothing but 4 by 9F. 4 by 9F. Option D. So these are the questions. You keep on practicing.